I thought they had it like 4th grade or something.
That was great. What? I can't believe I remembered all that.
All right, guys. So today, Miss Mahanna and I decided that we would just do straight notes for today. So we're not going to do the mistake notes. We'll probably revisit that again. And I'm going to go through section 1 with you. And I'm going to go through fairly quickly. Then we're going to get started on our lab. And it's going to be station labs. We're not doing all of it though. We broke down, we did like 4 or 5 stations for you. So we're not going to do all of it. Some of it's a repeat of what you did before. So we were like, okay, forget it. All right, so you've got 3 things here. You've got compound, solution, and energy. I need you to get this down. And sometimes I'll say not to write the whole thing. In this instance, I'm looking at it and I'm thinking we probably should. Actually, with solution, for us, just please write mixture with water. So solution with us, please just write mixture with water. Okay? We don't have to write an answer or anything like that. Just mixture with water. All right. So I know that some of you are still writing. This is just, kind of maybe a review. We're going to see this again. And Miss Mahanna and I kind of talked about it. We're not going to do a lab over compounds and solutions. We're going to do the properties of water lab. That's what we're doing today. Next time is going to be a acid and base lab with a pH scale, cabbage juice lab. So I feel like in bio, properties of water for bio is probably more important. And so I'm assuming you should remember what a compound is and all of that. So just be aware of that. But a compound is a substance that consists of 2 or more elements that are chemically combined. In a kitchen, this is the way I always think of it. In a kitchen, could I separate out a compound? In other words, can I, in the kitchen with my equipment, separate out water into hydrogen and oxygen? No, I can't. So if you think of a compound, it is chemically combined, it is not easily separated. You are not going to be able to go into your kitchen and separate out salt, NaCl. Can I separate out salt? No. That's what we're talking about. Does that make sense, Miss Mahana? Okay. Taylor? Not yet. We'll talk about that when we get there. Don't worry about that yet. A solution is a mixture with water, and I like to think of that. It's a homogeneous mixture. In other words, it looks the same throughout. So I'm going to ask you something. Can I separate out in the kitchen, could I separate out salt water?
No.
The salt from the water. Could I separate that out?
Yes.
Yeah, I could. I could. How would I separate it? Boil. And the water would go into the air, right? And what would I be left with? The salt. I could trap the water somehow if I wanted to keep that water, yes. Could I separate out sugar water?
Yes.
Absolutely I could. Yes, I could. So that's the difference. That's the way I kind of think of it. I might stop and think, can I separate this easily? If I can, then it's probably a solution. If I can't, then it's probably a compound. I'm not saying that's surefire all the time, but most of the time it is. Just ask yourself. Energy, capacity to do work, that's for us. You might have energy right now, enthusiasm. Look at them, all enthusiastic. Woo.
Yeah.
All right, so matter is anything that has mass and takes up space. I'm going to ask them something from physical science here.
We were supposed to remind all of you.
I disagree with Adam, but because it's possible to split an atom.
Yeah, and what do you end up with?
Nuclear explosion.
Okay, but what's smaller than an atom?
Quarks.
Starts with a Q. Yeah? Yeah, so you're right. All right, so matter is anything that takes up mass and has space. Or wait a minute. Anything that has mass and takes up space. Beep, beep, beep. Takes up space is also known as volume. What am I talking here? Two, mass and takes up volume. If I go mass divided by volume, what do I get? Density. Do you guys remember something? One of the properties of different elements is they have a specific what?
Density.
Density. Property of water has a specific what?
Volume.
Density.
Density. That's right. I think it's 1 grams per milliliter. Oh my word, look at me go.
We just did that.
So, I'm
Wearing
right.
a wire.
So, I'm podcasting. So anyway, so this is why density is one of the properties that you can find and you can use. Right here, because water has a certain amount of matter that it takes up. Atom? Yeah, well for us right now we're going to go with it. I don't talk about quarks, so element, substance that's made up of atoms. Valence electron in the outermost energy shell level. This is why you make compounds. I always talked about atoms being happy, elements being happy. They're sad if they're not, their valence, their outer shell isn't full. They're happy when it is. So they make compounds. Oh, wow, look at that. All matter is made up of atoms. Here's an example. I don't ask me what type it is. Picture. No, it's a picture of an atom.
But you can't actually get a picture of an atom.
There's one right there. Yeah, this is an artist rendition at least. All right, so atomic structure, you've got 3 different types of particles. Write these. If you know it, I'd still write it.
Are you supposed to storm all day?
Yes.
Yes, I'm sorry.
All right, so you've got protons that are positive. You always think of pro-positive. Electrons are negative, and then neutrons are no charge. So usually, protons and electrons will equal each other out. Therefore, an atom will not have a charge. That's not all the time, but usually it works that way. Protons and neutrons are in the nucleus of it. The electrons orbit, and we usually show them kind of orbiting, but realize that these orbits can be very large. So understand that. We already talked about that chemical bonds enable atoms to become more stable. I would highlight the valence shell. Usually it's 8. There's another one. There's another number that I would write down as well. Not just 8, but what else?
16.
What? Okay, I'd go with 2. I know what we just talked about, Tierney and Tasia, but I would go with 2 just because I'm thinking like with hydrogens, since we're going to talk a lot about water. Miss Mahanna, would you go with 2 or would you add?
I would go with 2. 2 and then 8.
So a valence shell, you should know this, I'm sure you do. It's the outermost energy level. That's your valence shell, outermost energy level. They want to be happy atoms, so they're going to try to fill that. There.
Happy hour.
All right, so covalent bonding, I would highlight that they share, and I believe you have to write that. Did you guys talk about polar and non-polar last year?
Yes.
Okay, good.
We're gonna go through that again.
A little bit. So atoms bond by sharing, we call that covalent. For us in biology, this is a pretty strong bond, just to be aware of that. I probably won't ask you that, but now if you go to chemistry, they'll say something different. I think they'll say ionic. It just kind of depends on what we're talking. I would highlight your example of water. Why? That's what we're dealing with today in the lab. That's why.
They have us write that.
Do you have to write examples,
Yes,
Tierney?
yes.
Yeah. Go ahead and then highlight water. If you want to write oxygen, you can. Probably not. You don't have to. If you didn't, that's fine. Ionic bonding is where they lose or gain an electron, they give up. That's 1 through 4, is it? Groups 1 through 4 that do the losing and the gaining. Those are usually your metals. I would highlight this. I would highlight this. I would highlight this. Now, it says that salt is ionic. And it says that these ionic compounds have a negative or a positive charge. Okay, so they're charged. That's important. Before I move on, I'm going to ask you something. We said that water was covalent. That means they're sharing. Okay? So technically, would water have a charge?
No.
No, would not. But wait. In the presence of water, salt will dissolve. And sugar, that's right. Like dissolves like. And it has to do with the charges. So how can that be if we are saying water is not charged, but salt is? Look on your next thing, and what's there on Roman numeral 3? What does it say? Polarity. That's right. That's exactly why that works. Do you have a question?
Actually, never mind, that would make sense.
Okay. So, water is covalent, and it is polar. What does polar mean? Think about opposite poles. Tyranny.
It has a charge.
It has a
Positive
charge.
and or negative.
Exactly. The ends are slightly charged. So therefore, like dissolves like. Charge dissolves charge. Does that make sense? All right. Sugar. Sugar, Tyranny told us, is dissolving in water. Sugar is covalent. Would sugar also have to be polar? If it's dissolving in water, which water is charged, would sugar also have to be slightly charged?
Yes.
Absolutely it would. It is polar. So that's why, do you remember those little things, and I know they're still doing those. Beep, 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 beep. You know, you put them into you put those electrodes in and they beeped. If it was charged, they beeped. I would
It's completing
say,
the circuit.
but did sugar go real low?
Yes.
Yep, that's why sugar's polar. Even though, I bet you guys learned it as covalent too, didn't you? Yep. So, like dissolves like. Charge dissolves charge. And we're going to talk a little more about that. So when shared electrons are more strongly attracted to one atom or another, that's polarity. So I need you to highlight that, and I need you to highlight that these are shared electrons. So your answer, they're covalent because they're shared. But one end, they're slightly more attracted to one end than the other. And that's how you get these charges, okay? The important part is that you know that they are slightly polar, they are slightly charged. I would highlight on here, one end or pole has a slight negative charge, one end or pole has a slight positive charge. I would highlight those. Example, water. You better write that example down because guess what? That's going to be on a quiz or it's going to be something here. And I'm not drawing this right now because your lab is going to show you, because of water's polarity, there are unique properties with it. And so we're going to talk about that actually in the lab and then the next time. So you're going to see some properties. The one property is that it's soluble. There's a lot of things that will dissolve in water. I want you to write this next to solubility. Like dissolves like. Write that down next to your solubility. So, Molly, what did I just say? Charge dissolves like dissolves like. So charge dissolves charge. That's right. So that's why I just talked about that. Your sugar and your salt will dissolve. They're either ionic or polar. Let's write below salt, let's write ionic. Below sugar, let's write polar.
It tells us.
Oh, well, write it anyway. It does.
That means it's important.
All right. I'm just seeing here. So your nonpolar, I would probably highlight that as well. Your nonpolar molecules do not dissolve in water. Highlight that. Your nonpolar do not dissolve in water. Oil, grease, wax. None of that dissolves in water. Number 4, we're actually is a property of water, and we actually will look at that today, surface tension. Water molecules can be attracted to each other because of their unique properties, because of the polarity. Hydrogen bonds, just a weak bond between two hydrogen atoms, and that helps with surface tension. That is really. So these are bonded together, the hydrogen bond, and this helps with surface tension. All right. So the next thing is we are going to get our lab. We're gonna hand those out. And I'm gonna tell you right off the bat with it, we want to, we didn't do that many stations. Our goal when we get back, and right off to the side, Miss Mahana, is the lab. Our goal when we get back will be from lunch, will be to do the lab. But you're gonna have to listen here.